My name is Nate Gemelke. I'm one of the co-founders of QueEra's and the Chief Technology Strategist. You know, if you're building a good organization, you're always hiring smarter people. And then you go out and you hire yet smarter people. And so I can say this as a founder, you end up being the dumbest guy in the room. And when that happens, you have a tendency to sit back and watch the operation run. Every time you add another individual into a mix like that, the results that you get are the anticipated one that you were after, but you also get the interplay between the people that you already had. Quantum computing is really unique in that it's cross-cutting. The people that we hire range from almost mathematician level abstract thinkers down to the extremely practical nuts and bolts on a table, kind of screw it together well type of people. And you know that each is going to do their job. What you never can calculate is how well they kind of feed off of each other. And I think the richness of the team is a huge part of why it is that we move a lot faster than we thought. Definitely, like, the creativity in those interactions is a huge part of why we undervalue what we've put together. And then once you see it, you really realize, okay, this is an engine that we built that is much faster than we ever thought it would be. So everything feeds off of itself if you're doing it right. Well, so one thing that we often hear is that atoms are slow. And part of this is because when we figured out how to make machines that are very programmable, one of the elements that we utilized along the way to show that we could do that is to literally physically pick up atoms and move them around in real time. Atoms are really light objects, 10 to the minus 25 kilogram. You would think that that's pretty easy to move, but we use lasers to move them unless they're small forces. So because of that, we've got this idea out there that implementing a gate is slow. However, we've learned how to do many of those gate operations in parallel. And that architectural sense of how quantum computers work in general, not just neutral atoms, but the decisions that you make when you invent an architecture give you a degree of parallelization that effectively makes that computer fast. So we've been trying to encourage people to think about the time to a solution to a useful problem as the right metric, rather than the speed of an individual gate that you might do along the way.